Hello all. Once again, we are together with another interesting topic in our second session with me. So it's going to be about self-driving autonomy with the context of remote sensing. We have Associate Professor Caner Güney from Istanbul Technical University, Department of Geomatics with us. Hi Caner. How are you doing?
Thanks. It's a pleasure to be here.
Yeah, it's always been a pleasure. And besides, we have Shai Ruth from Cognata, Director of Business Development. Hi, Shai, welcome.
Hi, thank you so much. It's a pleasure also to be here. Looking forward for a very interesting discussion.
Yeah, very nice to have you guys here. So I think it's going to be a very juicy and enjoyable conversation with three of us. And we take a look about what we are going to discuss today. So in terms of our childhood, there was a cartoon series called Jetsons. Probably most of our generation remembered that there were a family which are using the ultimate technological solutions such as flying cars, robots, etc. And what I am seeing, especially in the digital platforms of Intergeo now, it's becoming, more and closer nowadays. This kind of lifestyle, digitalization, flying stuff, etc. But the thing is, in that particular cartoon, there were still car crashes, even though they used the ultimate technology in flying stuff, but they used to have car crashes, which is leading us to discuss another topic. It's the importance of remote sensing and importance of mapping, actually. We are going to talk about the powerful self-driving autonomy solutions in terms of remote sensing. I would like to start with Mr. Caner Güney. Welcome again. I'm going to ask you three questions for starting. It's three of us, three of that will be linked somehow. You are free to choose which one to start. So the first question is, I want to start with the definition of autonomy, self-driving. How do we describe the self-driving, and then what would be the levels of autonomy? And the second, linked to that, how do we integrate the remote sensing tools and solutions on the autonomy in terms of creating maps, HD maps, or in terms of onboard solutions such as LiDARs, image sensors, etc. And the third one will be the integration between the industries. How do you see that the remote sensing industry will push up the autonomy?
Actually, it's important where do we start. And if you take a look from the perspective of Industrial Revolution 4.0, the answer would be different, because the autonomous vehicles is a disruptive technology. And the goal is not only transportation is here. And for example, what I'm understanding, if you call autonomous vehicle or autonomous driving, I'm understanding the transformation of the society. Mm-hmm. And not only from the transportation perspective, but also smart city perspective, mm-hmm. and the human behavior perspective, etc. And so autonomous driving maybe provide the transportation from point A to point B. But the ego-mobile, ego-driving, it's possible to provide this facility like the cartoon Jetsons. But mm-hmm. to think about more than one car, 100 cars, million cars, and the problem is getting complicated. Mm-hmm. So how to solve this problem? And the crucial thing is here, not only concentrate on the car alone, but also infrastructure, mostly connectivity infrastructure. It brings us smart city concepts. Because how can we get rid of the traffic lights? If we only concentrate on the driverless cars, then we need to use the traffic lights. But if we concentrate on the impact of the driving cars into the mass, we need to take care of the smart city infrastructures. This is the first part, and that's called in the literature vehicle to everything. Vehicle to everything. Vehicle to
it's an environment. Yeah, it's a environment.
Vehicle to vehicle, vehicle to social media, and also another approach in the literature. And this is a case connectivity, automated or autonomous, sharing and electrified. This the case acronym is important in the autonomous vehicle. And the problem is not only compete to mission without the human intervention, while also interacting with other cars, human-driven vehicles, plus dynamics of the environment, weather conditions, road conditions, etc. And if you take care of all this stuff, and the human understand the problem is really complicated. And before the 2000s, these problems handled with the rule-based approach. But after the millennium, we started dealing with these issues with artificial intelligence. And the artificial intelligence, especially deep neural networks and machine learning, is a good advantage for us to leverage the autonomous vehicles into the market. That's the first point. Second point, so we need also maps, because you mentioned about the sensors on board, like LiDAR, radar, ultrasonic, GPS, GNSS, and etc. And the camera, and there are also brings the data. And this data, and we use the two different maps actually. One is the HD map, already produced by someone else and installed in the cars. Sometimes offline mapping, sometimes online mapping. Online mapping means the data is coming from the cloud.
Yeah.
Like Microsoft Azure or Amazon AWS, publishing the data and get the data. Or it's, and second map is autonomous vehicle map. During the transportation, during the motion, vehicle also produce the map. So another problem, the combine of two different data sets for the control mechanism. And the sensor, we are using the sensing the environment, like the eye of the human. And also this sensing information brings the perception, what's going on around the car. HD map also, in which case, can be used as a map as a sensor, because the sensors are limited in the visibility of the distance, and the map brings the other data as well. Maybe it's not updated, but also brings the data. That's why we call it map as a sensor. And these are the produced the HD map. And another question is that HD map is a true term or not? Because the HD map is not only map, actually it's a database.
Yeah.
Like if you look at the NDS perspective, it's a SQLite database. Or if you look at the drive format, Open Drive or etc., it's again is a database, maybe XML vocabulary, or it has the metadata catalog. So it's a map or GIS. So I think this is the first perception, and also we can observe this. You ask the level of autonomies, and it starts from the level 0 to level 5, determined by the Society of Automobile Engineers. And let's get the reflection to the geomatics industry for the Intergeo. And generally 3 types of autonomy available autonomous vehicles, like partly autonomous systems, highly autonomous systems, and fully autonomous systems. If you use the total station, it's partly autonomous.
Yeah.
If you use the drone, it is highly automation.
Yeah, good.
But if you use the robot, you share through the LinkedIn, Spot, for instance, for like dog-like robots, and with the LiDAR, this may be autonomous, fully autonomous measurement. So as you see, driver is here corresponding to surveyor.
Yeah.
Okay. And maybe it's too long to explain, but
yeah, it's actually perfect. And I was actually asking another, I was preparing myself to ask another question about the AI, but you already mentioned in your answer starting from the first
but
question.
Let me add the AI perspective here. Also, I combined it for the remote sensing. AI is a really huge term.
Yeah.
Because in terms of autonomous driving, we use different parts of AI. For example, if you use the aerial imagery or satellite imagery, we can apply the convolutional neural network to extract the road, for example. This is just one part.
Right.
And then maybe if you thinking about autonomous driving in the simulation environment, like Cognata, maybe we need the reinforcement learning, Q-learning. It's quite different
for decision making.
Yeah, for decision making is a different part.
Yeah,
and as you see, and the AI is a different part of different views of the AI can be used. For example, in the beginning, we are just using the convolutional neural network to extract the roads from the imagery. But for the in terms of motion, we need, for example, recurrent neural network, because the SLAM is continue measuring and providing the position and mapping. That's why you need the memory before, and then you can utilize the recurrent neural network, for instance. And then you see those are the different, and they all. It's also we need a time because we need to maybe 20 different AI module in a driverless cars. But we have just a milliseconds to make a decision. How could we achieve this one? This is also another problem.
Yeah, I believe in autonomous industry, this would be the biggest part of the decision making, the time frame. And also, when we talk about the time frame, when taking a decision, it's also the rules of ethics. When giving a decision, you also consider the ethics and safety. So we will come to that topic. I want to discuss it with Shai, actually, but up to now it's very nice that I got lots of info from your answers. So Shai, in this direction, the market is actually growing day by day. We are seeing lots of startup business all around the world, also technological giants like Google, etc., big investing on this kind of stuff. How do you evaluate this market from your perspective as a private sector businessman? And also, I would like to add another question on that. How is Cognata solution, how are your solutions opening a perspective to autonomous driving?
Okay, so I will start with the first question. I think it's a very good question. Cognata is an autonomous simulation platform. We help autonomous vehicle companies to train their vehicle better and faster by using our simulation platform. Now, we have established our company at the middle of 2016. It was about 5 years ago. And back then I was asked, the notion was that every OEM has their own autonomous vehicle program. And all the CEOs were claiming that by the end of 2020, everyone will be driving their autonomous vehicle freely and the problem is already solved. And I was constantly asked by my colleagues and by my investors, what problem are you solving? If it's already solved, then why are you here for? And at around 2017, 2018, there was what I would like to call the walk of shame of all those CEOs that had to admit that the problem is a lot harder than expected. An autonomous vehicle driving freely on a public road is something that we are still, there is some way that it needs to pass, mostly because of the way that AI is being trained. And it needs a lot of examples and a lot of work in order to reach to a level of a human driver. Now, the way that we at Cognata see the market, we see the market as a market that is now matured enough to a point where there is no longer a blank statement of I'm doing autonomous vehicles. They no longer exist. What we see is I'm doing autonomous vehicles for I'm doing robotaxis. I'm doing last mile deliveries. I do autonomous mining equipment. I do off-road application and so on.
Yeah, segment specific solutions, you mean?
Exactly, exactly. And this is why I also think that the level of autonomy, the classic level of autonomy between 0 and 5 is no longer valid. And I've said it, you know, in order to create some controversy, to make the discussion interesting, although everyone work according to that scale. And this is because I believe that the scale goes on the responsibility. There is the area of autonomy where the driver is still responsible. That's usually the 0, 1, 2, 3. And that's where it's still a bit of a more of a simple use case. You have what we call the ADAS, the safety equipment that help all of us to maintain our driving in a very high quality or in high safety level without getting into accident, but still it's my responsibility to control the vehicle, and therefore the task is easier for the ADAS to come to the market. And then there is a very, very, very clear path where you're saying that it's no longer the driver's responsibility. It's now the autonomous vehicle responsibility. And now there is a huge climb in the level of autonomy required and the level of training required in order to reach that goal. And this is exactly where companies such as Cognata, which creates simulation for autonomous vehicle, really kicks in, because now the amount of knowledge that you need to give to the autonomous vehicle driving engine is almost endless. We need to train it how to detect between different objects, within, as said before, different light condition and different weather condition. And therefore, we're talking about a simulation platform that needs to train the AI with almost infinite number of use cases. And in order to do that, we'll build a very, very robust platform that is capable of creating millions of different scenarios and then running them in the cloud using a lot of GPUs, enabling our customer to really reach to their goal faster by reducing a very large number of physical driving on actual roads and moving them into a simulation platform. And this is how we see the market evolving in the next few years, where our customers are telling us it's not just an autonomous vehicle, it's an autonomous vehicle to do X, Y, Z. And this is exactly what we need from you guys in order to help us. So the market is maturing. We see a clear path toward commercialization. And this is exactly our mission. And this is Cognata's product in order to provide with that solution.
Perfect, perfect. And another question to you, Shai. If I remember the times I used to play video games, especially the Grand Theft Auto. You remember that GTA? It's a very nice real-world simulation from the human movement, human behavior to traffic behavior, and it was also including weather conditions, etc. So, as a summary, can we say that it's a kind of GTA playing somewhere in some virtual environment that your driver actually, which is trained in an AI universe, let's say. Is it correct to summarize such that way?
So I'm smiling because you are taking me back again, like 5 years ago, where we had on our competitive landscape, we had also to add GTA, because so many different companies who just started told us that they're using a very special version of GTA that someone created that helped them to create synthetic data for training.
Yeah.
Actually, that was both a blessing and a curse. Because now we're getting into a point where Cognata is very different than the rest of the herd. And GTA is really nice, by the way. It's a lot of fun. I'm playing it on my spare time, not with my kids, because it's way too intensive, but it's amazing. But what it does not provide, it does not provide the level of realism needed to train an AI for autonomous vehicles. And this is where we get into something that is being called, in the professional AI terms, the domain gap. It basically says that unless your synthetic data, and that is basically the data that we're creating with the simulation platform to mimic to the best that we can the real world, if it's not accurate enough with a great mimic of the cameras, the LiDAR, the radar, everything that you need, and the level of training that you will get when working on that data would be great as long as you will work on GTA. Once you will take that data and try to apply it in the actual roads, you will see a phenomenon they call a domain gap. The results will be poor. And this is something that the entire industry had to cope with for several years, that problem of AI scientists who are trying to use synthetic data to do exactly what you just mentioned, and it did not work. In Cognata, we have developed what we call the photorealism synthetic engine, which basically mimics much better and with a lot of hard work, the actual world. And basically, in order to do that, we're actually using physical-based rendering. We take a digital twin that is based off high-definition maps, and on top of that, assets such as building, vehicles, and
different layers.
Building, we're breaking them into different ingredients. And those ingredients are receiving from us with different metrics, such as reflectivity, immersivity, intensity, all kind of different level of elements that really help later on to create the data, the synthetic data, that actually mimic the real world. Combining all that together, this is exactly where we differentiate ourselves from engines such as GTA, which is great for gaming, but not as great for AI training.
I understand. Perfect. Thank you.
Can I say something here?
Yes, please.
HT maps also produced for different purposes. One of them is the autonomous vehicle, what the Shay mentioned about the safety domain. And the safety is important. But the other computer games, you don't need the safety. You can crash anywhere. Like vacuums, and they use the SLAM, but they try
more fun, but less practical for autonomous.
On the other hand, HT maps can be used for the smart city and other kinds of transportation, like highway transportation and mass transportation, etc. This is the one point. Another point is there is a big debate actually in the autonomous vehicle world, and the HT map is really necessary for autonomous driving or not, especially Tesla. Andrei Karpathy, head of AI in Tesla, mentioned about that mapless autonomous driving is also growing up because they're just based on what I mentioned in the previous part, autonomous vehicle, the map produced by the autonomous vehicle. And they are just trust the data sets coming from the autonomous vehicle itself. But on the other hand, there is another camp, and they say that the HT map is also as a sensor, as a baseline data, ground truth data, and this is also important. So, but on that, this is the two camp. Tesla and other funds, they say that producing the HT map is not a scalable business. What I mean, and the producing the HT map has a pipeline. Like you have a special van type vehicles, spatial hardwares, softwares, and you start producing, you sense the environment first, thereafter you render this data as a map, and then you annotate the data on it, etc. And you finish the job, but the data is old at the moment. You need to update these maps, and it takes time, 1 week, 2 weeks, 1 month, etc.
Right.
So
and meanwhile, life goes on and traffic goes on, everything goes on. You are not updated at all.
Not only updating, but also producing the scalability limit. It has this limited scalability.
Right.
And
so I agree about that. I would suggest that you would take a look at Mobileye's latest REM technology, which is basically the way that they automated HG maps. It's truly amazing. Google it later, or maybe some other people who are listening to us. They're basically leveraging their existing equipment in current vehicles driving around the world. And they really created a robust and scalable way of creating high definition maps. Truly amazing work, not ours, not related to Cognata, but still they've showed that there is a way to scale the HG map, which I completely agree that all the rest of the companies are doing amazing work, but it's not scalable.
Yeah, it's true. And if you look at if you Google, how much kilometers available roads all over the world, 6 million kilometers. And to think about producing the HTML of 6 million kilometers is a huge job. And for example, deep map say some you can come across on the web. Deep map says the $5,000 per kilometer the production of the HD map, and this price also is not negligible, and this price also reflects the car owners. Also sensors, and the other way the Tesla say that the LiDAR is the expensive instrument. It is expensive. And also there's a gap between the when you processing the camera views, cheap camera views, and the LiDAR data point clouds. There's also another point. And also this cost also brings to the car ownerships. And these are the some obstacles in front of the this autonomous driving. These are the really crucial points to discuss.
Right.
But on the other hand, there is another one, online mapping. And if the autonomous vehicles produce the maps of the environment and share this data with the other autonomous vehicles through the cloud.
That's the point I was going to ask. That's the point I was going to ask. It's a recent thing that in Turkey also we had this discussion with a group of people as you are leading. The importance of the shared data. It brings the cost for all of autonomous vehicles producers, and it's also government involved. The government's also involved this kind of regulations, especially, and it leads us another question, another topic of producing maps and how to share, how to store, how to share, and how fast we can deliver, how fast we can share. So these questions, I think, require another maybe 1 hour, 2 hour sessions to discuss. Perfect. So
but very basically, if the community all around the world can produce the OpenStreetMaps for HD maps, it can be solved very quickly.
It's a global solution. Yeah, it's a global solution. Definitely. Let me check the clock, and I'm seeing that we have 5 minutes or 4 minutes left. So we are going to check if there is any questions before we wrap up. And let me see from the screen, the second screen. I'm not seeing any upcoming new questions. The last one is from 2 hours ago. Perfect. So let's talk about the future for last 2-3 minutes. Let's talk about the future. How do you foresee the future? Can you draw us, Shai, please, can you draw us a picture? Can you take a screenshot of your future estimations in this area? How it's going to be?
So I'm assuming that you're asking about how do I see the future, right?
Yeah. What will we see in the future after all this training, simulation, and stuff? You know, what will come?
So I think that in the next 5 to 10 years, we're going to see that use case solution of autonomous vehicle really coming on and on. Meaning we will start to see autonomous vehicle driving along with regular vehicles on commercial road. All of them will be geofenced, meaning one of the ways to introduce autonomous vehicle faster while there are still technology limitation with the ability of an autonomous vehicle to really understand everything would be to geofence it, meaning that he will be driving in a very, very specific area where he was very, very thoroughly trained, or he will not drive in the night, or he will not drive in the rain, in order for him to be able to actually succeed in all kind of different regulatory testing, ensuring its safety, without basically saying that we will never see any autonomous vehicle commercially in the next 20 years. So there will be a gradual road of ever-growing geofenced vehicles that usually will just become wider and wider in terms of their geofenced. Ultimately, once we will see regulatory efforts coming through along with technology improvement that will really enable the vehicle to be 99.999% safe, and that's not where we are today, we will see those limitations being lifted. And I would say that in 10 years, we will start to see a more of a widely accepted autonomous vehicles. Until then, a gradual effort.
Perfect. And Janesh, what do you think about the future? How it's going to be?
Actually,
your
so close, I
perspective?
guess, and not for level 5, but level 4 is we are using today, and especially for shuttles, buses, last mile deliveries, and Germany and UK also developing the legislation. This is important in terms of act, and but they are mainly concentrated on the lanes and lane keeping systems, lane changing systems, etc. But it brings the hands off from the wheels. That's the important product. From the sensor perspective, and the other kind of the lidars are available. The solid state lidars, flash lidars. These are the important developments, and also it brings the velocity, and maybe it reduces the cost of computation, and also the price reduction of the prices. These are the important. And for the hardware perspective, the prices are decreased. The goal is under the $5,000 first, but today they are expecting the lower. And whenever the goal is not for persons. Actually, with autonomous driving also, ride sharing is developing, and the goal is integrate to each other. And rather than the personally owned autonomous vehicles drivers, how can we share these rides, like bike sharing? How can we share these ones also, because it brings the reducing the carbon emissions, etc., parking problems.
Definitely. So it's going to be a kind of environment problem involved. It's going to be a community problem involved, and it should be considered as a bigger picture, and it should
multidimensional problem.
Yeah, exactly. So let's check once again the questions, if there is any question, and then we will close the session. Okay. So, guys, thank you very much for joining us. It was a big pleasure to have you here, and I believe it's a very nice conversation, juicy conversation for me. I believe it's also very nice. It was also very nice for our audience. Thank you very much, and see you.
Bye-bye. Very much. It was a pleasure. Thank you. Bye-bye.